This example is going to walk us through unions and intersections. So these are just ways that we can combine or think about the combinations of sets. In fact, let's do a small example. The union symbol. If I have a set A and I union to it the set B, I'm thinking about X could be an element of A or it could be an element of B. So I want to think about adding these sets together, right? There's A, there's B, then it could be anything in A or anything in B. If I think about the intersection of two sets, A and B, this is the set of elements that are inside A and inside B. So if I think there's A and there's B, it's no longer everything. It's not the or statement, but it's the and statement. It's only the elements that are inside A and are inside B. So let's think about this first example here. I want to draw these on the real number line and then see what the resulting intervals would look like. The union of -4 to 0 and -1 to 4. So if we were to draw this on the real number line, there is -4 to 0, and it's open. And then I want to union this with the set -1. So -1 is somewhere right there, up to 4. So I'm going to start at -1. In fact, open circle at -1 technically. And anything up to 4. So in total, I've really just highlighted everything from -4 up to 4. So I really just add these two sets together and I get the result. Let's look at the second example, -infinity to 1. So I'm going to start all the way down here at the limit of my left axis and go all the way up until I hit 1 with an open circle there. And I want to add to that the set 1 to infinity. So I'm going to start at 1, again with another open circle, and go up to positive infinity. So I can see here that I really just take the entire real number line, except I skip over the value of 1. So that would be the interval representation. Or as a set, you could be any real number except just not equal to 1, right? You start at -infinity, you go up until 1, but then these open brackets mean that you skip over 1, and then you continue the rest of the way. All right, our third example is an example of the intersection. I want to look at the set -5 to 0. So there's -5, here's 0, open circles on both. And I want to find the intersection of that with -2 to 2. So here's -2. Let's give ourselves an open circle. And let's go all the way until we hit 2 with another open circle. So what are the x values that are in common here? So definitely not this. This was only inside the first interval. But then the overlap that we have picks up at -2, but we don't actually include -2 because -2 is not in either of these two sets, or it's not in that second set. So this will be -2, and we go until, do I hit 0? I do not, right? Because 0 is not inside both of these sets. 0 is not inside that left set. So I stop at 0, right? And all of everything past 0, that was only inside that second set. It wasn't inside the first set. So the intersection of -5 to 0 to -2 to 0, the numbers that are inside both of those intervals are the numbers that are in between -2 and 0. In our last example, the closed interval -1 to 3 intersect the open interval 5 to 7. So let's put -1 right there. 3 will be right there. And we have a closed circle and an open circle. And the second set will be from 5 to 7. So here's 5, Here's 7. Open circle on both. So the union here, the sets don't have any overlap, right? There are no real numbers that are in this set, but also inside this set. So this is empty.